So this chapter or section is all about what they call two variable data and scatter plots. You've been dealing with a lot of two variable data and scatter plots for quite a bit now. You did it with linear functions, you did it with quadratic functions. Anything with two variables um, kind of relates to this. Now, what they start off doing is giving you a couple of different examples of sets of two variable data. One is, height and weight. Another one is population GDP. Another one is runs and wins. Okay, now, when you look here, we can use this two variable data to create what we call a scatter plot, right? And if we go to our definitions here, and I would pause and write these down, but a scatter plot is a graph displaying a set of data as a collection of points. So it's basically taking a bunch of points and plotting them on a coordinate plane. Okay, now this two variable data that we're talking about is basically data that are described by two different variables, such as height and weight. These data can be graphed on any coordinate plane. So looking at this, going back here, what they did is they basically took the two variable data and put them on these horizontal graphs. But what we can do now is we can take these and write one as a dependent variable and another one as a dependent variable. And you'll see when I rotate here, one becomes your x coordinate, another one becomes your y coordinate. Now, when we write these as ordered pairs, what happens is all of these points become ordered pairs, and you can look at this data. Now, this is what they call a scatter plot here, this graph here. It's taking all of this two variable data and plotting it on the coordinate plane. Now, what we look for is there a pattern with the data? Do the points line up in a linear fashion, a quadratic fashion? Which way do they line up? So when I look at height and weight, then I compare population, right, versus GDP. If I go here, right, you look at that looks closer to a straight line. And then I'll actually take the runs and wins, and we'll get something like this, right? Now, taking a look at all of this data again, right, you're going to answer questions on it. Okay, so as we look at it, the first graph you see, right, is this one here. Okay, they're going to ask you the points on the points for the population GDP scatter plot are. So I'm going to go to this scatter plot here. Right, when you look at the population GDP, do these points tend to line up in a close linear fashion or spread out? And as your population goes up, is your GDP going up or is it going down from left to right? So when we look at this, the points for the population GDP scatter plot are, right, are they very close to a straight line or somewhat close to a straight line? I would say they're somewhat close to a straight line. And the scatter plot goes up from left to right. So when I look at this scatter plot, right, they're very close, somewhat close to a straight line. And when I look at it, as my x values go up, my y values are going up. Okay, so oops, sorry, this one is very close. I'm going. And there we go. All right. Now the next one. The points for runs wins scatter plot show, is it no pattern, a rough linear pattern, or a close linear pattern? Well, if I go to the runs wins, is there any pattern here? Can I take any graph and come close to every point? And the answer to that is no. So right now there is no pattern for that one. Okay. Now, The next one. The points for height weight scatter plot are blank close to a straight line. The scatter plot goes blank from up or from left to right. So when I look here, right, for the height weight, this is not close to a straight line, but it's somewhat close to a straight line. Now, again, if I look here, are my points going up from left to right or down? They are going up. All right. So getting used to these scatter plots is actually not very difficult. Okay. So now, so when you look at this next example, every year Bear Lake High School has a spring dance. Over the past 5 years, the students planning the dance have collected data to see how price of tickets compares with the number of students who go to the dance. So they give you this data here. And what they want you to do is plot this as an ordered pair, ticket price and attendance. So right away, when we move on, here's ticket price, here's attendance. And if we take these and create ordered pairs like this, 10, 120, 20, 40, 15, 80, 5, 160, 25, 0, right? What I can do now is take and plot these ordered pairs. And when I plot these ordered pairs, what happens is the scatter plot will either have a relationship or no relationship. If it has a strong relationship, and if I look at this, these points tend to line up in a very straight line. Now, that tells you that this has a linear relationship. Since I can look at that and the slope of the line is negative, this has a negative linear relationship. Okay? So anytime we're looking to set up a scatter plot, the one thing we want to know is some information about the variables. Okay? We have two types of variables, right? The first one is the independent variable, or what they consider the explanatory variable. And this is the one that, right, basically we would say nothing changes. So in a real problem, it's a variable that's likely to produce the change in the other variable. So when you look at it, the amount of house you can afford depends on how much money you can make, right? So the amount of money you make is your independent variable. And we'll talk about here the dependent variable would be how much money that would give you to spend on a house. Okay, so the independent variable, right, depends on nothing. The dependent variable depends on the independent variable. Okay, so here when we look at it, the price of the ticket is the independent, and because of the price of the ticket, right, the higher that price went, the attendance changed, right? That's why attendance is the dependent variable, because it relies on the cost of the ticket. All right. Now, looking at this to kind of understand the explanatory and response variables, right? If you had this list of explanatory variables and this list of response variables, which ones go together? So if my independent variable is number of hours worked, what would that help me with here? Well, number of hours worked kind of goes with amount of money earned. The model year of a car, right? That there is going to have anything to do with cans of cat food? No, it's going to have resale value. Temperature outside goes with the amount of electricity needed to heat the home. Number of cats, right, tells me how many cans of food you must purchase, right? So again, all these response variables rely on the explanatory variable. Number of movies downloaded goes to data used. An age of tree determines the height of a tree. Okay. All right. So let's take a look at some of the vocabulary that they've introduced here. First is correlation, right? Which is the measure of the strength of the relationship between two variables. So what happens here is if I create 3 sets of coordinate planes, if I plot ordered pairs in here, if I have a bunch of ordered pairs or points and they're all over the place, this has no correlation. However, when I look here, if I have some points, right, and they have what we call a linear relationship, they're basically saying that you could take and draw a line through that data and come very close to every point. Okay, you're not going to touch every point, but as long as you can come close to every point, this has what we call a linear relationship. Now, since you're going uphill or the slope of this line is positive, right, we say that this is a positive linear relationship. Okay, now, what happens if I have a relationship like this? Okay, again, can I draw a line through the middle of this data and come close to all the points or in the center of it? Yes. So here, this has a linear relationship also, but we say it has a strong linear relationship, or sorry, strong negative linear relationship because the slope of this is negative. Okay. Now, we're going to come back to the correlation coefficient. Dependent variable, remember, it depends on the independent variable. We usually say this is your y coordinate. Okay? Your independent variable, all right, or your explanatory variable tends to be your x coordinate or your input value. Okay? Next, we talked about negative correlation is when your ordered pairs line up in a negative slope. Positive correlation is when your dots line up in a linear fashion in a positive slope. That's a positive slope. That's a negative slope. Okay, so now a scatter plot again is just a bunch of points plotted, and then you have your two variable data. So let's take a look here. A scatter plot is the best way to display two variable data. And it plots the two variables as x and y pairs on the Cartesian coordinate plane. Now, what we say, so we say the explanatory, right? And to be honest, I don't really like that. I like to say the independent, because that'll be used in science more, variable is likely to produce change in the other variable. This is plotted on the x-axis, right? The response, right, or dependent variable responds to the change, and this is basically your y value. Okay? So all two variable data sets have two variables. An explanatory, or we said independent, and a response, that's your x value, by the way, and a response variable or dependent variable, which is your output value or y value. Okay? Now, the correlation coefficient, and we'll go back up here, the correlation coefficient up here, also known as the R value, is a number that expresses the strength of the correlation between two variables. It also shows whether the correlation is positive or negative. So as we go down here and talk about this, a correlation is a number that explains the strength and direction of the relationship between the explanatory variable and the response variable. Now, the straighter the line of dots, the stronger it is. So when I look here, this would be very strong, right? Then the next one, this would be kind of weak, right? And you can go kind of in the middle and go something like this is strong, but not the strongest. The closer to a straight line, all the dots line up, the stronger the correlation. Now, a positive correlation is data that appears to go up from left to right. So this would be a positive correlation. A negative correlation is when your data goes down from left to right. Okay, if there is no correlation, right, data are spread out across the scatter plot with no visible pattern. So there's basically nothing you can say, right? So now, if we look at here, it says list 2 examples of positive correlations. One that people would use is, the years of education and say your income, right? The more years, the more you make. The more years of education, the more you would make. Another one would be, sales increase and say profit. Okay, so this is a way of saying, like, if your years of education is your input or X value, meaning you're dependent, your outcome, which is your Y value, would be higher income. Okay? So here, the first one. In a negative correlation, as the explanatory variable increases, so as you move to the right, the response variable, right, decreases. Because if you look here, this would be a negative correlation. As you go to the right, you go down. That means it's decreasing. Okay, an example of this, let's go age increases, right? Your running speed then what? Decreases, unless you're me. I would school you in a race. All right, so now, if the data in a scatter plot are truly scattered, meaning they have no relationship, then they are said to have no correlation. Okay? So, if one line contains all the data points, meaning all of them line in a perfectly straight line, that is a perfect, right, relationship. If the data points form a tight cluster but do not fall quite in a line, that would be strong. So something like this. It's not a perfect straight line, but I can draw a line through it to get close to all of them. That is strong. And it's weak if the overall trend of the data is in one direction, but no points form a tight cluster. So here, if we had to look and talk about the correlation, so this is your R value. If your R value is near -1 or +1, that means it is a perfect correlation. Okay? Now, this being negative just tells you you're going downhill. This being +1 tells you it's going uphill. Now, if your R value is between -1 and -0.7 or 1 and 0.7, that means it's a pretty strong relationship. Now, if we tick down and get close, a little closer to 0 here, so between 0.7 and 0.3, right? That's a moderate. That means it's close, but not really close. And the closer we get to 0, the weaker we get. Okay? And if your R value is 0, that means there is no correlation. Okay? So, again, a strong might be something like this. Actually, let me do it over here. Strong might be something like this. Moderate might be something like this, right? Weak means it might be something like this. And then no correlation would be just a bunch of ordered pairs all over the place. Okay? Now, the variable used to show, right, correlation is R, which is known as the correlation coefficient. Now, if I look at strong positive correlation, since it's a positive correlation, it would be a positive number, we'd say 0.9 or 0.8 would be pretty good. A weak negative one might have, say, negative 0.3. A strong possible negative correlation would be like negative 0.8. So again, strong is between negative or 0.9 and 0.7. No correlation would mean it'd have a 0. So the 5 properties of R values would just be up here. Okay, so let's take a look here. So how do we find the R value? This is actually something you do need the graphing calculator for. So if you don't have one, let me know, but you kind of do need one. So the first thing you want to do is you want to hit second and then the 0 button on your calculator. And you're going to arrow all the way down to, you have to do what they say, turn diagnostics on, right? So you're going to go diagnostics on, enter, enter, and you're good to go to start there. Now next, what you're going to do is enter your data. So when I look at letter A here, I'm going to enter that data by clicking stat. I'm going to hit enter for edit. And then in the left-hand column, all I'm going to do is plug my data in. I just hit 3, enter, 6, enter, 7, enter, and so on. So I already plugged this data in to speed it up. Now, if I hit graph, right, notice how it comes up. Now, I did have to change my window. So X min means what's the smallest X value on the graph you want. X max is your largest. So I want to go from I want to be able to see all the way through 14 on the X-axis, all the way through 22 on the Y-axis. So I set my Y max at 25. Now when I hit graph, I see my data. If you can't see your data, right, you have to go up here where you see plot 1, hit enter to make sure it's highlighted, and then hit graph. Now to get my R value, I'm going to hit stat again, arrow over for calc. And what I'm going to do is look for linear regression, which is number 4. So I arrow down, hit enter. Then I'm always going to go all the way to calculate. And if you see here, right, my R value ends up being, how do I go back? Stat, calc, 4, enter, 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 enter. And you look, your R value is 0.981. So it's 0.981, which means that is a very strong, right? And in this case, positive linear correlation. Okay, so when I know that if I look at my graph alone, doesn't it look like these points line up in a straight line? Okay, now let's go and do the next one. I'm going to go stat, edit. I'm going to go 2, enter, 5, enter, 7, enter. 2, enter, 5, enter, 7, enter, 10, enter, 18, enter. Then I'm going to arrow over right? Arrow over. And then I'm going to enter 25, enter 24, enter 22. Then I'm going to go 5 and 3. Now, when I hit graph, I want you to predict, just by looking at points, do you think that's going to be closer to 1, closer to 0.5, or closer to 0? Remember, the stronger it is, the closer to 1. But in this case, it's actually going to be closer to, potentially -1, -0.5, or 0, because it has a negative correlation. So let's go. Stat, add arrow over for calc, choose number 4, enter, 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 enter. And if I look, my R value is 0.89. So that's negative 0.89, sorry. Negative 0.89. So that means it's a strong negative correlation. Okay. Now, just by looking at this, is this going to have if you had to look at it, first off, the line I put through here, does it get close or not close to all the points? Comes pretty close. So this would be strong. Since you're going uphill from left to right, strong positive. So would negative 0.9, 0.9, negative 0.25, or 0.25 be the R value? 0.9 would, because it's strong and it's positive. Here, right, if I look, this tends to be, again, pretty strong. But since you're going downhill, it's strong negative, right? And when I look at my options here, well, I know it's strong and it's negative. These are both weak. So it's going to be negative 0.95. Number 3, if I look at this, right? If I draw any line through here, is it going to come real close to many of these? No. So these are strong R values. This is going to be on the weaker end, and most likely it would be more positive than negative. I guess you can go either way with it. But me personally, I would say it's no correlation or very weak at 0.40. Okay? Next. Which of the following is not a possible R value? Well, right away, you need to know that an R value is between -1 and 1. So this one cannot be a possible R value. Which of the R values represents a strong correlation? Closer to 1 or -1 would be a strong correlation. Now, 0.7 is still strong, but -0.9 is stronger. Which one would have the weakest correlation? Which one's closest to 0? 0.2. Okay, now with these, look at this first one. What I'm going to do is plot the ordered pairs. So I'm going to plot 0, 2, -1, -1, -4, -3, then 2, 5, and then 3, 7. If I look at this data, is that a strong correlation or a weak correlation? 1, it's positive, tends to be strong, so you know 0.97 would be the most accurate. Okay, the next one, if I plot 0, -1, -2, 1, -3, 0, 1, -2, and then 3, -3. Here, this is relatively strong, and since it's a negative, right, slope, it's a negative strong correlation, so -0.93. So basically, this just continues with the same stuff. I want to basically give you a chance to try it on your own and let me know if you have any other questions. All right.